Hey guys, how you doing? This is Coach Scott with Purple Wave Chemistry, and of course we've had some bad snow, but we're okay. We're going to make it. So today we want to talk about moles. What is a mole? We've had lectures about these. This is just to reinforce this a little bit. So again, I think I mentioned to you earlier, the term mole comes from a German chemist called Oswald, who uh, coined the term molecule, right, for molecule, right? So, of course, most of us know or we've heard that a molecule or a mole is a unit of measure, an SI unit of measure, and it measures 6.02 times 10 to the 23rd, anything, okay? They can be molecules, they can be atoms, they can be golf balls, they could be grains of sand, whatever. All right, it's sort of like a dozen. Okay, if I have a dozen eggs, how many eggs do I have? 12. If I have a dozen golf balls, how many eggs do I have? 12. Yeah, if I have a pair of socks, I have two. If I have a pair of eggs, I have two. All right, so it's just a counting measure, and that's what we use moles for. So this is a really big number. Let's look at it. So if I have 602, all right, and then I'm going to put 21 zeros after there now. 1, 2, 3, 4, 5. All right. 6, 7, 8, 9, 10, 11. Still going. 12, 13, 14. Wow. 15, 16, 17, 18, I'm carrying over, 19, 20, and then 21, 22, 23. That's a bunch of zeros, right? So let's see. So this would be a million, 6 zeros after it. So, okay, what else we got? So this would be a billion, 9 zeros. This would be a trillion. Okay, trillion, that's what, 12 zeros? This would be a quadrillion. Quadrillion. All right, and that is 3, 12, 15 zeros? Yeah, 15 zeros. That's a bunch still. All right, and let's see. Then this would be, that's a quadrillion. This would be a pentillion. Pentillion. And that's 6, 9, that's 18 zeros, right? From these right here, right? And then this would be a heptrillion or heptillion. Heptillion. That's a bunch. So that's 602 heptillion zeros after this, the 602. That's a whole bunch of things, right? And we've talked about this in class, what they really mean. But let's talk about what they mean for us. All right, so we're going to take a little break. Okay, guys, so let's think about this. Okay, so when we had the snow and ice, I started doing some experimentation, and I made the best omelet I could, right? For instance. So what this omelet was I had one duck egg, right? And I mixed it, broke it up, and mixed it with two hen's eggs, chicken eggs. Okay? So I had 3 total eggs in there. So let's say I made 5 more of these, a total of 6 omelets. 4, 5, 6. Okay? 6 omelets. So how many dozen omelets would be my 6 omelets? Would be a half dozen. Agreed? A half dozen omelets. Okay, so how many duck eggs did I use to make these omelets? Well, let's count. 1, 2, 3, 4, 5, 6. So I used a half dozen duck eggs to make my half dozen omelets. Okay, how many hen's eggs did I use? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I used a dozen hen's eggs to make my half dozen omelets. So how many total eggs did I use? That's duck and chicken eggs. 1, 2, 3, 4, 5, 6, 12, 18. So I used a dozen and a half eggs to make my half dozen omelets. Okay. So let's say this is a molecule of water. Okay, and I have a half of a mole. Half a mole. So if a dozen is 12, so if I have a dozen, that's 6. So I'm dividing 12 times 2, cutting it in half. So what would be a half a mole? 6.02 times 10 to the 23rd divided by 2. That'd be 3.01 times 10 to the 23rd if you use your calculator. So that would be a half a mole. So how many oxygen atoms would I have if I had a half a mole of atoms? 1, 2, 3, 4, 5, 6. Okay. So I would have a half of a mole, like I did with a dozen of the oxygen atoms. Okay. How many hydrogen atoms would I have? What I would have a full mole, or 6.02 times 10 to the 23rd, because I had 2 of those. So I'd do that 2 times what half would be 1. So how many total atoms do I have? I'd have 1.5 mole because I have many, many, many more atoms than I do molecules. I have 3 times the amount of atoms than I do of molecules of water. Make sense? So we have a formula for how we can conduct or how we can calculate, and this is going to come to play really huge later. It's this. N, which is the number of moles, is equal to N, the number of particles that you have, divided by Na. So Na is Avogadro's number. Okay. Na, write this down, equal Avogadro's number, which is 6.02 times 10 to the 23 third. Avogadro, yeah, we'll do that. Number. And then the big N, the capital N, all by itself is your number of particles. So if I have 6.02 times 10 to the 23rd atoms of iron, right? So I'd have 6.02 times 10 to the 23rd divided by Avogadro's number, which would be 6.02 times 10 to the 23rd, which would be, come on, so N would be, 1 mole, okay? And we'll be using these a whole lot as we go on, and we'll have some more that we'll play with. So anyway, this is Coach Scott with Purple Wave Chemistry saying, be safe. Hullabaloo, connect.